All right, let's get started with 3.5, applications of slope, and again, application just word problems. So in the word problems, they may ask for rate of change, but rate of change is slope. And slope is rate of change. It's the same thing. Okay, like I said before, mathematically, or math people, we like to change the meaning or the words for things once you get used to them so that we look smarter than we are. Okay, so rate of change is slope. It's just, in word problems, we refer to it as a rate of change. Rate is a comparison of two different quantities. A very common comparison would be miles an hours or dollars an hours. Very common rates that we compare. So for an example like this, if you drive 288 miles and use 9 gallons of gas, what is your rate of gas consumption, which would be the rate of change? And I think we've talked or seen an example like this before. This would be kind of a proportional example because we assume that you would have started, I guess, at 0 miles, went 288 miles, and used, in that time, 9 gallons of gas. But you would have started at 0 miles and 0 gallons of gas used, I suppose. So on this one, you can just, since it's looking for gas consumption, by the way, we're looking for miles per gallon on this stuff. Okay. So this sets up our gas rate of gas consumption. There we go. Miles per gallon. Now, what we would really like here is a rate of gas consumption. We want to know how many miles you can go in 1 gallon on this. But they told us you can go 288 miles after having used 9 gallons of gas. So that gives us something to start with. And really, in order to do these problems, all you got to do is pretty much change that fraction line into a division sign right there. So all I'm going to do is put in my calculator 288 divided by 9, and then I push enter. Boom, about 32 miles. 32 miles per gallon. And that'd be the rate of gas consumption. Some people write it like this, miles per gallon. I suppose on the homework they'll specify that, but either one of these should work. All right, Miranda rides her bicycle for 3 hours and 32 miles, and it's 32 miles from her house. After riding for 12 hours, she is 122 miles away. Now, sometimes we get caught up with a proportional thing and say, can't I just set this up as a proportion, where you'd say 32 miles, that's a 2, by the way, in 3 hours? Wouldn't that equal 122 miles in 12 hours? No, this is not what we're saying. This is not a proportion. That's not what we're saying here. What we are saying, though, is that since we do want a rate of change, which, remember, is just another way to say slope, is I would really like to be able to use the slope formula, okay? And what we have here are 2 ordered pairs that we can use. This first one being 332. Let's see if I can give myself more space there, though. That would be considered 332. And the second one here is 122. Well, how do we know which one goes where? It's because the x values, especially if you see time, time is always going to be your x values right here. And it has to do with what we call dependent and independent variables. On this one, the distance that Miranda is from her house will depend on how many hours she's been riding the bike, right? Now, we don't know how many miles she started away from the house, which is why this is not proportional. Otherwise, if she started at her house, then it should be, okay? But that sets us up to say, well, I'll say this is x1, and that's a y1 right there. So I'll make that 32, 3 like this. And then this will be my x2, y2 there. So x is 12, y is 122. Now, some of you say, well, we're going to have some negative values here. That's true, but they're going to have 2 negatives, which is going to make this positive. Either way, though, I'm not going to do it in my head. I'm going to use the calculator for this. So 32, and the N over D button first, but 32 minus 122.
It's 90.
If you did all the work there, you would get negative 90 over negative 9. But yeah, like I said, the calculator has already simplified that for me as just a positive 10 right here. So now it does want this as a rate, right? So that would be, that's how many miles that Miranda's going for every hour right here. Now, again, just to show that this wouldn't make sense here, 3 hours and 32 miles, 12 hours and 122 miles, neither of these would have given you 10 miles per hour, but together they will, because it's after riding the bike for this many hours. And even from this, 10 miles per hour, yeah, you could say, well, how far away from home was she when she started? It appears that she was 2 miles away Not that we needed to know that, but you could figure it out. The way I looked at this is I said, well, in 3 hours, she's 32 miles. So I just went back an hour, which would have been 22, and then another hour would have been 12, and then another hour, which would have been 0 hours. And that would have been 2 miles away. And it kind of works the same way. This one was kind of quick because it just 3 times 10 would be 30 miles. That's how far she traveled in the 3 miles. And then the extra 2 was added on. It shows the same thing with 12. 12 times 10 is 120. There's the extra 2 miles. All right, this chart shows living wage jobs in Rochester, wherever that is, per 1,000 working age adults over a 5-year period. Don't be tricked too much by all the values in the table. This one only wants us to focus on these 2 values. First, 1997. Try to use a different color there. 1997, which is right here. And then 1999, which is right here. These other values I don't really care about, so I'm going to pretty much cross these out so we don't have to look at that garbage, right? Now, it's possible on the homework they may say 1997 to 99 and then give you a whole different question saying 1998 to 2001, something like that. But this one is 97 to 99, okay? So this is a slope problem because it is a rate of change problem. So let's set up our slope formula here. And again, if you see time, that's usually your x values, and then looks like our y's are the jobs on this one. The number of jobs, living wage jobs in Rochester will depend on the year. So y is on top, x is on the bottom. First off, I'd say this is x1, y1 for me. So that's 1997 in the denominator and 620 in the numerator. And then my second value here is x2, y2 right there. Sorry about the handwriting, but the y value is 740 in the numerator, 1999 in the denominator. And again, the calculator will do all this work for us. N over D, 620 minus minus 740 all over. I know not everyone needs to do this one, but 1997 minus 1999. Well, if I could type that in right, that'd work better. There we go, 60. Oh, it didn't really need the fraction line there. I'm kind of anticipating that, but 60. Now, again, this is a rate, so we do want to label this. It's a word problem as well. That'd be 60 jobs, at least at this rate, per year on average. Now, did it actually go 60 jobs per year? No, you can look at the data here that shows that it doesn't, but on average, that's what it would be. You can kind of see that it's positive, right? Like we started in 97, which is the smaller year, at 620, then it improved up to 740. Yeah, if this had gone down, then we would have said a negative 60 jobs. Negative just loss of jobs per year. Yeah, and the formula, the nice thing about the formula is very, very consistent, okay? All right, so same thing on this one. In fact, it even tells us the x and the y value on these ones, but then it gives us a different population in year, but again, they've already told us x was the year, and then the population was is the y value there. So let's set this up. We're gonna have to make this a little bit bigger. And so I'll say that this is x1 and this is y1 right here. So x1, 1947, with a population of 2,860,700. And then this would be our x2, 1998, which is our denominator. And then the y2 is the population, 2,878,200. And again, for me, I like to just put this directly into the calculator. And remember, the numerator is people, the denominator is the year, so it'll be people per year or population per year. I guess rate of change would be people per year. And yeah, once again, the rate of change is the slope, which is why we are using the slope formula. So N over D button, 2,860,700 minus 2,878,000. I forgot a zero there, didn't I? 200 all over. I typed that? Yeah, that looks good. 1947 minus 1998. Enter. Oh, it's an ugly number. I don't really want the fraction on this one, so I'm going to push the double arrow button above enter, and it shows this is 343 point. I'm rounding here. I don't like to round with people because I don't know what 0.14 looks like. I'm going to round to the nearest person on this one. 343 people I'll abbreviate that per year. About 343 people per year. All right, let's find the slope from this graph. Now, you'll notice about this graph is that the scales of our x-axis and also, well, I guess the y-axis is the same. It's just 1 unit for every line, but the x-axis is pretty jacked up. Every line is representing 10 units, whatever the units are, right? In either case, though, we got to figure out the ordered pairs. We need 2 for sure ordered pairs that we can use on this one. It looks like there's several. The first one I saw, I guess for me, is this one right here. And again, that ordered pair would be -60 and then 5.
So,
All right, so that's one of the ordered pairs. Now I'm going to use an ordered pair that I'm looking at. You don't have to use the same ordered pair, okay? But I kind of want to purposely make it far away, but this one right here will do. Which, by the way, is the y-intercept, because the x value is 0, and then the y value here is -5, it looks like, okay? Now, you can see, well, how do we know that each line on the x-axis is 10? Because it has 20, well, 20, and then there's a line between, so each line is 10. So 10, 20, 30, 40, and so forth. So again, that's the beauty of choosing whatever points you want. Some of you may have used this point up here. What is that? -90, 10. Some of you may have used -30, 0. Or even this one, 30, -10 right there. All of those points will work in getting you the slope. Now, you'll see here, there's actually 2 questions. It wants the rate of change and the slope, but it's the same question. So whatever you type in for your slope is going to be the rate of change on this, okay? Now, we've done a lot of the slope formula, but I'm going to go back to the, and you could use the slope formula on this one. I don't know. I do like stair steps, though. So I'd say, look how far down I got to go on this one. How far down? Now, this one's not just a matter, well, I guess downwards is just a matter of counting the lines, right? So 1, 2, 3, 4, 5, 6, 7, 8, 9. I went down 10. It should be simplifiable. Let's see. So that's down 10, which means it's a -10 numerator. And then we would go to the right here. Again, each line represents 10, though. So that's 10, 20, 30, 40, 50, 60 to the right 60. So that's a positive 60. Well, that's not too bad. That will simplify into a -1/6 right there. So that'd be our slope. And so if it asks for the rate of change, -1/6 right there. But do be careful, because a lot of the times students miss this problem on the homework, the one that's like this, because they don't notice that the scale has changed on this, okay? Now, of course, the slope formula would still work. I'll show one of the setups, even though there's kind of 2. So you could say I guess it'd be 5, -60, like this. And then we have the other ordered pair, -5, 0. Yeah, you'll get the same exact answer on this. So this one wants the same thing. Remember, rate of change is slope on this. But the scale, that's the main thing here. The scale, each of these x-axis numbers, each of the lines goes up by 20. And then, yeah, it's showing each of the y-axis lines or units going up by 400, okay? But we just need 2 different ordered pairs to use, and there's so many to choose from on this one. It doesn't matter which 2 you choose. If you choose the 2 that are closest together, you still may have to do some simplification because of the scaling on the axis, though. So you know what? I'm going to start with this one. What is that? 43,200. And then I guess I'll choose this one. It doesn't matter which 2 you choose, but that's 120 and 1,600. Okay. So I did the stair step thing on the last one. I'll use the slope formula on this one. So I'll start with the green ordered pair, which is 3,240 or 43,200, either way. And then the orange ordered pair, where the 1,600 goes in the numerator and then 120 in the denominator. I'm just going to put this into the calculator, see what I get. So N over D, 3,200 minus 1,600 all over 40 minus 120. And it gives me -20. So that is my slope. That is my rate of change. If these were labeled, it'd be the Y label over the X label. But it's not, so I can't. And by the way, that's -20 because this is going from left to right downwards. So we should have known that it was negative even before we started the graph, although it kind of comes out when we use the formula one way or the other. just the way that I have this, let's look at the purple one first, right? So I would say I go down and then to the right. Okay, so down is negative, right is positive, which makes the slope a negative. Now, if we reverse that though, and I said I went up, right, so I'm going this direction, I'd go up and to the left. Well, now my numerator is positive, but my denominator is negative, which would still produce a negative slope. There we go. We're almost there, though. So y and x can vary based on the ordered pair. Again, the y and x in this slope-intercept form, that is an ordered pair on the line, right? It just needs to make it true. M is the slope, B is the y-intercept. Just remember to write your y-intercepts as ordered pair. That's the main thing. All right, so on this graph, we got to write the equation for it. But let's set up our equation, okay? So y equals mx plus b. Y equals mx plus b. There we go. And I know that m is the slope and b is the y-intercept. Of course, it's in the equation, so I don't want the ordered pair in the equation, right? It would just come out. It comes out of the equation, though. Now, you can find the y-intercept first. You can find the slope first. It doesn't really matter. The y-intercept is usually pretty easy because it is it's just a visual check. I can see that the red line is going through this y-intercept here at the ordered pair 0, 4. Now, knowing that, I can replace the b. It's positive 4, so it will stay plus, but there's a 4 right there, okay? So all I need now is the slope. With all the methods we have for finding the slope, you can choose the method that you like the best. I see that it goes for this other ordered pair right here at -4, -1. So you could use the slope formula, but like I said, I don't know. I'm kind of partial to the stair-step method. So I do see that this goes up. How far up? 1, 2, 3, 4, 5. So right away, I can see that my slope will be, it's up 5, so that's positive 5. And then it would go to the right. 1, 2, 3, 4. Right, 4. So 5/4. Yeah, let's go. That cannot be simplified. If it could be, then I would want to. And the calculator will do that for me as well. But 5/4 will do. This is the equation in slope-intercept form, which is exactly what we wanted. This is kind of the first time we've seen a visual check on the y-intercept. I think we have, but now we're explicitly combining this with not just the y-intercept, but also now the slope, which we have a little bit of practice with, hopefully by now. Let's show the formula on this one, okay? Just to be clear on that. So I'll do the green one first, -4, -1. And then the purple one, 0, 4, like this. So if you subtract in the numerator there, -1 minus 4, that will give you -5. And in the denominator, -4 minus 0, -4. But those two negatives are going to make that, in the end, a positive once it's fully simplified. I got 4 minutes. Here we go. So first thing on this one, I would notice that my y-intercept is 0. Again, it's not just 8. It's -8 because of the minus sign right there, right? And I can put that on the graph. Remember, that's the first thing you need on a graph is a point. Now, we do know the slope on here, but 0, -8, right there. 0, -8, okay? But then I would need my slope as well, which is just the coefficient of x, -2/3. Now for me, I would write this fraction, again, the -2/3 like this. That means I'm going to go down 2, and then the 3 is positive. I'd say that's to the right 3, okay? Well, down 2 to the right 3 from where? From the point I just put on the graph, okay? So let's see if I can do this decently. So down 2, down 1, 2, and then to the right 1, 2, 3. And that would be my next ordered pair. Now remember, it's kind of like a stair step, although even doing this by hand or even on the computer, you only need 2 points like I have right there. But you'll notice that I can pretty much copy this stair step going backwards as well, right? To the left 3, up 2, and that would give me the next ordered pair. And then to the left 3, up 2. See, this is where the stair step thing really comes into play once we start taking the graphs or the equations and then needing to graph them like this. Okay, and this just gives me a nice pattern. Well, maybe it was nice before, but still nice, where I can graph that, okay? All right, let's go ahead and graph this equation, but again, the first thing I would want to do, I mean, you could do this with a table, by the way. It's just, you'll see that there's only a few values, or every once in a while you'll find a value that works for either x or y, where they're whole values. Both of them would be whole values. What we need on this one is for both values to be whole. Now we can force this to happen, or we can just change this into slope-intercept form, which will do the work for us, okay? So I'm going to take this equation, 4x minus 3y. Once again, it's like solving the equation for y. So we're going to say, go ahead and solve for y here. All right, y won't equal a number. It's going to equal an expression. So that means that the 4x I would have to zero out. So I'd have to say subtract 4x. Again, I'll stack that with the 24, even though they're not like terms. And I'm going to keep those two terms separated because they're not like terms to combine. So 4x and positive 24. But I want the x in front so that it looks like slope-intercept form, which is y equals mx plus b, like this, okay? So again, notice that the x term is first. Then we get the b term, okay? So in this equation, by subtracting 4x, that zeroed out the 4x there. Remember, when you drop this 3y, it's negative 3y here because of the minus sign. And then the final step here is to divide all the terms by the coefficient of y, which is negative 3. And this will have solved for y. So you see, it's really only 2 steps, and it usually is only 2 steps. Once in a while, they'll throw you a curveball and put in some distribution right here, but for the most part, we see it's 2 steps. Isolate the y's, divide by the coefficient. So we're left with, now that's a phantom 1, by the way, but 1y equals negative 4 divided by negative 3 would be positive 4/3. And then 24 divided by negative 3 would be negative 8 right there, okay? Now that is slope-intercept form, where we can see that the slope here is the coefficient of x, which is 4/3. Okay, so I'll describe this. 4 is positive, 3 is positive. That means you're going to have to go up 4 and to the right 3 if you're going to use the slope here. And I'm going to do that, but where do you go up 4 to the right 3 from? Well, that's where we need the y-intercept, which right now, again, it's not just 8, it's negative 8, and it's the ordered pair, 0, negative 8, okay? So I have that y-intercept. I can put that on the graph, 0, negative 8, which would be about right there. And, you know, I'll go ahead and label that as well, 0, negative 8, okay? Now, from that point, I'm going to go up. All right, I'm going to go up 4, and then to the right 3. So I go up 1, 2, 3, 4. So that shows up 4. And then to the right 3, 1, 2, 3. And whether you're looking at this as streets, like we've talked about before, or a stair step, this right here takes us to the next ordered pair, which appears to be 3, negative 4, right? But like I said before, you can put the other points on the graph because it really isn't too bad. Up 4 to the right 3, and that would tell us where the next point is. And you can go up there, up 4 to the right 3, and that's about as far as we can go on this graph, okay? So the final thing here that we would want to do is just graph the line, right? Just got to go through those green points and the purple point as best we can anyway. So let's go ahead and, we want the line function, something like this. And I'll just put a couple arrows on the end of the line to show that it goes on forever. So this is, again, it's nice because we found these ordered pairs with the slope after finding that the y-intercept is a very nice ordered pair. On Canvas, you only have to graph 2 of those points, but I graphed all 4 because it's a little bit more thorough. And again, I use this y-intercept and then the slope to figure out where the other points are.